My name is Alec Cook. I'm an application engineer for GoEngineer, and I will be presenting design for manufacturing today. There's going to be four topics that I'm going to get into today. The first one is minimize. The idea is we're going to want to minimize fasteners, the use of fasteners, and try to reduce down the number of parts in an assembly or your final product. The next topic is going to be reuse. So, if kind of what I mentioned there, if you're going to spend the time to design a part, try to make it reusable, so that it's valuable to you guys, and you guys can have it on your shelf and have multiple parts that go play into that. And standardizing parts, and I'll explain that. I got a nice little chart for that. Design intent. If any of you guys have been to like our training or like our essentials course, you probably have heard this word or this phrase, design intent. It's designed for change basically, and being able to quickly adapt and change your model if you need to. But here I'm going to relate it to symmetrical parts and self-locating parts. And the last one is going to be top-down design, and that's going to be parts locating parts. And again, this is another one of those terms that we use, as you probably heard of, like top-down design or bottom-up. I did a lot of top-down design, but in a multi-body part when I got started early on, and when I was going to school at ASU, which is not really ideal. Top-down design is ideal in like an assembly, where you start with a part and then you can make virtual components around that part and build off of that. And so let's go ahead and get started with minimizing parts in assembly. So I got this little example of a roll bar assembly that I created, and it consists of 24 different parts. So between all the fasteners and the side pieces in the bottom, which you can quickly see that this is going to take some effort to keep on your shelf. You're going to have all these sheet metal parts. You're going to have to reach out to somebody who's going to cut them, shear them, plasma cut, water cut, some vendor that's going to make these 3 sheet metal parts and then also bend them for you. Additionally, with this rod here on the top, you're going to have to reach out to a machinist or a welder or however it's made, but it's going to be a manufacturing process where either you weld on some big lock washer or big washers here, or maybe it's machined down, whatever it may be. But it's an added step, another person that you have to maintain a relationship with and have them create these rods for you, inventory and that kind of thing. And then obviously the last part there is all the fasteners. So you have to find some vendor, call Granger up and see if they got these fasteners in stock. And you have to worry about your consumer losing them or replacing them with different fasteners. They take up space on the bottom. Maybe something could have gone under there when you were designing the whole thing that this drops into. But I think you get the idea. We might be able to reduce this down into a smaller assembly. So here's one way that I came up with that we could reduce this down. We're still going to need the rod, but we can reduce this into one sheet metal part that has no fasteners, and it goes to one sheet metal vendor, and it has little bend-in tabs. So this reduced our 24-part bill of material list down to 2 parts. So that's the whole idea of reducing the number of parts in your assembly. One thing that came to mind for me too, when I thought of minimizing the use of fasteners, was the traditional Japanese wood joining. So that's why I got this little picture here, but they haven't been using fasteners for a while. Early on, they were creating all of their buildings and structures. They were using these really cool, unique types of joiners. I thought this was a great way to explain how to like reduce the number of fasteners. Maybe it's just something that we've become familiar with in industry, to just put a fastener there to hold it down. Maybe it's ideal to use a snap fit clip instead of putting a fastener like you saw on my example with the headphone holder, the little rack that I had that clips onto the top of my cubicle. I didn't need any fasteners. I didn't need to drill any holes into my cubicle. It's a simple design. It pops off easy if I need to, and it really is not taking that much force to hold headphones up, so fasteners weren't really needed. But it's just something to keep in mind maybe when you're designing, to start your design, is to keep in mind maybe we don't need fasteners wherever they're being used. So again, just to reiterate the impact of minimizing parts, this is less parts to design, less parts to document and revise. It reduces our bill of material, the parts that we have to receive in, inspect, store, and handle. Also, the less labor or energy to get those parts created, as you saw with the sheet metal part and the rod. Cut some cost down by not having to have so many parts made at a sheet metal house. The next topic is reuse. I'm going to briefly discuss standardizing parts and then get into design library. Design library is inside of SolidWorks in the task pane, and it can be overlooked. It was overlooked by me for quite some time. It definitely has some value to it, and so hopefully by the end of this I'll show some value to design library. Standardizing parts. The first thing that I think of was when I was about 14, I got a 1966 Mustang that my dad and I restored. And as I was working on it, I quickly found that like a lot of the bolts were 1/2 inch back on that model. And so I could kind of guess what ratchet or tool I needed before I was even going to take off the part, or as I was going to take off the part, I could kind of guess and most likely was right. And as you see here with this chart, foreign cars, 10 millimeter size is common. But the main idea is that you want to reduce down the number of different types of fasteners it takes to make your assembly and make it more consumer friendly, where they can use less tools to change out parts or any maintenance that may come with your assembly or your product that you're having, and it ultimately will lead to a happier consumer. Moving on to design library. So design library lives over in the right hand side in your task pane, and it's got the 3 little books here. And it has a collection of different parts, features, and assembly files that live in there that are already there, and you can add your own. I'll show you guys how to do that. We're going to start with exploring design library and adding in some fluid power ports that will be machined out. So let's go ahead and jump into the software. All right, so design library. We click here, drop it down, and we're going to go over here to features, inch, and fluid power ports. So as I hover over, this opens up and shows the part that we can insert in. So this is going to be a cutout, and what I think of is for this would be like a machinist. You're going to send this off to a machinist, and they have these tools in their tool crib or in their machine, and so they don't need to buy any new tools to create this part. Also, if you guys are familiar with configurations, you can have these parts that are in your design library to have multiple configurations. So once you select your configuration, it's asking you for a reference edge in this nice graphics area. So I'll go ahead and select a concentric reference edge, and it puts it right there in the center. And it's all set. Just click the green check, and it adds it over here in my feature manager tree. It does have a little different icon. It has a little design library icon. So we'll go ahead and pop in another one. We'll do this rectangular fluid power port. This one's neat because we'll have 2 faces to align. So this one's wanting us to select an edge and then select another edge, and that'll get it located in place. And then it has some locating dimensions here. So we'll just put 0.5 and 0.5 to get it centered up. And that looks like it's right where we want it. And then we'll go ahead and click the green check. And as you can see, this was pretty quickly and easily done to add these 2 fluid power ports that would have taken some time to design these every time you needed to put those in. So you could even go as far, so these are like the female version, you could go as far to make the male version and have that for whatever part's going into this when you go into the assembly. The next part that we're going to have here is going to be the rectangular key set, and go ahead and drop it in here, and then it's going to ask us to select a placement plane. I'll select my configuration here, and then it's going to ask me to select an edge. And as you can see, it's kind of in the part there, but you'll see here once we select this edge, it's taking its time again today. Then we'll be able to locate it. And let's just bring it back into view. So if we move it to 0.25, that brings it all the way up to the face. And then if we come here, we can adjust the length of that key set, so the rectangular key set. So we can set it to 0.75 inches. All right, and there it is. Somebody's asking where I got this part from. I got this part from one of our examples that we have in our book. So if you guys are ever interested in our essentials book, this is covered in that book, how to add design library parts. So this is as far as I wanted to go, but this is with this part here. But it quickly shows you guys how you can add in parts that are from your design library, and you can adjust any of these ones, make configurations, that kind of thing. So let's go ahead and jump back into the slides here because I want to get into how to create these design library parts. So as you can see here, these are some forming tools that we have that you might have seen if you guys are a sheet metal house, or if you guys have things sent out to a sheet metal house, like maybe you create AC units or create sheet metal parts that are stamped. But there's embosses, lances, louvers, extruded flanges, that kind of thing. And so we're going to go ahead and create a keyway that's going to be put into a sheet metal part. So I'll go ahead and open up this part. This is the form feature part. And so what we're going to want to do is we're going to want to create a stopping face. So first I have to put in a split line for this, and that's going to define where the hole is going to be cut out. So we've probably seen these where you put a screw head in there and then drop it down, and then something's mounted on your wall and it supports itself. So this is a common cutout. And so this is, again, the concept that I'm going for is reuse. So if you know you have a sheet metal vendor that has this specific stamp, or maybe it's a good idea to find out what they have in stock, for tools. That way they don't have to go buy a tool to make something that you designed. Instead, if you design all their tools they have, you can take advantage of the tools they currently have on their shelf. So we'll go to the sheet metal command manager and come over here to forming tool, and we'll select stopping face. So the stopping face is what you think of as when this presses into the sheet metal, where does it stop? So that's where it's going to stop. And then the faces to remove is this face here. We want it to cut that out once it's pressed in. And then the next thing is we're going to choose an insertion point. So this little red dot here is the insertion point, and that's just going to help us align it when we are dimensioning it once we've inserted it into the sheet metal part. So I'll go ahead and click the green check and accept our changes here. And you'll notice in the graphics area that it's updated a little bit. We've got some graphics that are changing. We got blue for the stopping face and red for the part that's going to be cut out once it's pressed in. So once you've created your part and you've went through the forming tool and selected your stopping face and the face that is to be cut out, we'll go to a file and do a save as. And then from the save as, we'll come over here and we can select form tool. So it's the .sld ftp. And once we select that, it's automatically going to take us to the folder where our design library holds all the folders that you're seeing over here on the right hand side in the task pane. Keyhole is the name that I was going to name this, and as you can see, I've already saved it, so I'm not going to save it out. Again, this is where you save it. So you go to Save As, choose Form Tool, and then you click Save, and then it'll automatically save it in your design library. So now when I go over here to Design Library, you can see, and it displays a nice little graphics of the part that you created. It's in your design library, and now you can reuse it for different sheet metal parts. So let's go ahead and put that into our sheet metal part. So we'll put it on the sides, the two side faces of this sheet metal part here. So we're going to put them here. So we can click, drag, and then drop it in onto the face that we want it to be in. And as you can see here, you can see the stopping face is right there. So it's stopping, and it's going to press in and press through just like that and make a keyway. So let's go ahead and we can even rotate it down. So we'll just do 90, and that we'll rotate that down, and then we'll go to position it. So we'll select the position from the property manager here, and then just using Smart Dimension, we can easily dimension this part into place. Maybe we want it 40 millimeters from the face. Then we'll go ahead and click OK. And once it's in place, we'll click the green checks to accept our changes here. There it is. With a few button clicks, the part that we created, we're now reusing it, and sheet metal parts that we're using. So again, the concept here is you have your sheet metal vendor has all these tools that they can punch in to your part or to your sheet metal, and it might even be just a good idea to find out what they have on their shelves, and you can start using parts that you weren't traditionally going to use, or take advantage of some things they can do, and taking advantage of your design library. So that's how I showed you guys how to create a design library part and then how to insert them in. So again, just to reiterate, we want to use standardized parts. So if there's common fasteners like an M10 or something, it makes it easier for your consumers to have those tools on hand, and then take advantage of any like mold tools, dovetails, as you guys seen with some of the tools or parts that I make, and any forming tools and that kind of thing. All right, so the next one is going to be design intent. Again, this is commonly used in the SOLIDWORKS terms, and so I'm going to show you guys how we are going to relate to self-locating parts and symmetrical parts. So on the right hand side here, I got a couple of examples that make sense. I'm sure we've all dealt with that issue where you go to like drop a fastener into like a cylinder, and it kind of doesn't fit right, or it's not quite long enough, and so like you kind of just have to guess when you drop it in, is it gonna land in that hole, and you're fussing around with it. And as a consumer, yes, that can be annoying, but you probably only do it a couple times. But where this really impacts your company is when it's on the assembly line, and the people assembling your product have to drop in hundreds of these little pins or hundreds of these little springs every day. And doing something as simple as adding a chamfer here makes it drop in a lot easier. Also, making symmetrical parts. So if you can get away with it, say you had the left hand and right hand side, I think this is a little bit self-explanatory. It might be ideal if you can make a one part, and that goes back to maintaining one thing on your shelf instead of having multiple items on your shelf. And another thing that I like to explain here is tab and slot. So this was brought up to me in 2018 when I was doing update trainings, is the tab and slot feature in SolidWorks when it came out. I was speaking to a guy and metalwork, and he had some problems with his guys laying out dimensions when fabricating, and I can relate to this. I've been a victim of it. I've just accidentally dropped it, was off by something. Maybe they said, hey, just punch a hole every 7 inches apart. And so like you can do math in your head for a while. You're like 7, 14, 21, and then you make a mistake. And now you have a hole that's off. So what do? You plug weld it, and it's all this rework. So what he did to eliminate the measuring error that was happening with the guys on the shop was use tab and slot. So from the sheet metal tab, if you select tab and slot, this will allow you to automatically insert tabs and slots. So it's pretty intuitive. You select an edge that you want the tabs to come off of, and then you select a face that you want those tabs to go through to. And you can see in the graphics area that it's creating these tabs and slots. And there's quite a few different options. You can choose the spacing, the quantity of tabs. There's quite a bit of adjustments. How much clearance is around there? Maybe you're going to plug weld these out on the bottom. That's kind of the idea that I was going for. And this eliminates people having this is a self-locating fabrication process. So it goes past just self-locating parts. So we go ahead and click the green check, and then you could just drop this in, and the guys don't really have to make mistakes with their tape measure, and you could just plug weld these out on the bottom. So if you guys have like a water jet or plasma cutter or something like that, this is an ideal way to pre-cut your material so that you can align it a lot easier and make less mistakes. But also, I just want to showcase tab and slot. I think it's a pretty cool tool. So again, that was design intent. We want to take advantage of patterns, and you're going to see that in the next example. Didn't really show too many pattern features, but in the next example that I have, I'll show some pattern features, and kind of relates with symmetry. And then also keep in mind making your parts easy to retrieve or handle an insertion. And from a consumer end, they may do it a couple times, but it really impacts you on the floor of your assembly line when your guys are like assembling parts. And then also keep in mind to try to make parts line a little bit easier. So the last topic I have for today is top-down design. So top-down design, I always try to use an example of like maybe you're making attachments for like a robotic arm, and you're going to make like a hand that can grab a grabber or something. So maybe from the person that you're designing this from, they send you the end of the robotic arm, and then you create a hand that can grab something or what have you. But you started with the robotic arm, and then you build off of that. In this exploded view, you can kind of see that. You can see how they're going to drop in. I have this dovetail here that's going to drop down in to that slot, and then these little channels are going to align with the little cutouts here. I designed this little Sonicare toothbrush holder to replace a shelf. The Sonicare kept like falling off the shelf, and so I also wanted to create a top-down design, kind of apply a lot of these things that come with this topic of design for manufacturing. One thing you can notice too is there's symmetry and this pattern here that is with the holes. So if you install this plate backwards or upside down, it doesn't really matter. You don't have to break out the spackle and start fixing your drywall because the holes were off because you installed it upside down or something like that. Just unscrew it, flip it over, and put it back in. And yes, I did use some screws. You do have to do that sometimes. As you can see here too, I took advantage of dovetail. The idea is I could make this plate reusable. For instance, my wife probably doesn't need a little razor holder to shave her face. So maybe if I wanted to make one for my wife, I could make one that holds different things like maybe makeup and things like that. But I could just 3D print a brand new or just another plate or multiple plates and mount these on my wall, my bathroom, and then just have like little interchangeable mounting devices in there. She has like 3 different makeup bags, and they all have different things. So maybe she could just like take one out and attach it to the little wall mount, and then take it off and replace it with a different one. Maybe she's using something different. That was the idea, is to make if I'm spending the time designing this, make it reusable. And then for top-down design, is I started with this plate, and then I created a little device here that was built off of this plate. So I used, if you guys are familiar with it, offset entities, and I did I don't know, like a 1/28th, or no, like a 30-second offset, or no, it's probably 64th. I'm always working in fractions. Made a little clearance so this thing can drop in there pretty nicely. And then I designed off of that, and made like a cube and then cut out some holes and designed this part. And my initial design, I had its own little slot here for the charger, but I realized too, like I needed to have better design intent and change it. And so that it made sense to put the charger underneath where the Sonicare went. And then once I did that, I put the Sonicare toothbrush right on top, and then the charger can wrap around the outside and plug in. If I don't want to like overcharge the battery or do any damage, I can just have it plug in there and have it tucked away. This is kind of a top-down design. This is kind of an all-in-one for this design for manufacturing. So we're taking advantage of making parts reusable. So in this wall plate, taking advantage of symmetric and pattern parts, and then reusable design library parts like dovetails, making your parts easy to manufacture. So like you can't install this backwards or upside down or anyway, and it's pretty self-explanatory. There's a fillet here to help you align it. If you spun this around, it's definitely not going in there. So that was kind of the idea when I designed this. All right, so just to reiterate, for top-down design, we want to simplify our assembly instructions to make these parts easier. We want to prevent stacked parts from getting stuck together. So if you have best way to explain that is if you have a box of springs, if you've ever had a box of springs and you go to grab them, they're all going to kind of like intertwine together. So if you can make parts that don't lock together when you make a ton of them, that's always good. Avoid difficult parts to handle, like maybe there's like a small little flange that's sticking out that now you have to design some custom shipping foam to protect it so it doesn't break off when you're traveling it, or issues like that. That's top-down design with parts locating parts. So I see that we're hitting that 30-minute mark, and I want to be respectful of everyone's time. So again, thank you guys all for coming. I'm just going to quickly go through these and then open it up for Q&A. So again, minimize is the key topic here. We want to reduce the number of parts that it takes to make our final assembly. We want to reduce fasteners wherever we can. Maybe they're not necessary, as I mentioned, but we're just used to it, but you probably could get away with like a little clip on top. Make parts reusable. That goes back to the design library. Find out what your vendors are using to design your sheet metal parts, or any of your things that you're making. Maybe it's a mold tool. Maybe they have like specific plates that fit well. And then have good design intent for self-locating parts and symmetrical parts. And top-down design, one of my favorite things that I've gotten a lot familiar with and gotten away from multi-body part designing and designing actual parts and assembly that I can 3D print. Thank you all for attending. My name is Alec Cook, and I am an application engineer with GoEngineer.